All right, ladies and gentlemen, check this out. See it up there? You can see it in your notes. We'll do a few examples here, and we'll get back up to the board. We're going to do some translating at the board. This is what we're going to start off with here. It says, a contest is to be part of a promotional kickoff for a new children's cereal. The prizes to be awarded are shown in the table below. And you can see the grand prize is a Disney World vacation plus $2,500. That sounds pretty awesome. 4 first prizes, 35 second prizes, and of course, 85 third place prizes. Those are worth $25 each. So as you guys know, in this chapter, we're not using our calculators, but these numbers are going to get kind of big. It might be useful to use our calculators at some point in here, but let's at least set this up by hand. First question says, how much money will be awarded in the promotion? And I want to do something wrong, and I want you to see what it is that I'm doing wrong. I want you to be able to explain it. So check this out. If I try to answer question A, and I do this, if I say $2,500, because that's the grand prize, plus $500, plus $150, because that's second place, plus $25, because that's third place, is that going to tell me how much money will be awarded in the promotion?
No.
Why not? What's wrong with that? Ashlyn? Yeah. They're going to show up more than once, right? Now, one of them will only show up once. Which one only shows up once? The grand prize shows up exactly one time. But, as Ashlyn mentioned, there's like 35 second places and 4 first places, so on and so forth. So instead of me going 500 plus 500 plus 500 plus 500, what would be a more efficient way of doing that? Multiply by 4 to get 2,000, yes. So here's what I'm going to do. We will get rid of a couple of those here, and I'm going to say 2,500 happens once, but as you mentioned, 500 happens 4 times. So I'm going to put times 4 plus, and of course, second place is $150, but there's 35 of those. And so instead of going 150 plus itself 35 times, I just go 150 times 35, right? So 150 times 35 plus third place prize, $25, but there's a lot of those. Bless you. So we're going to multiply that times 85. So this will give us the total amount of money awarded in the promotion. Does anybody have their calculator with you? If you do, feel free. These numbers just get pretty large, right? So I think this would probably be something, these large numbers, I don't know that I would expect you to just like whip this out real quick on a quiz. So use your calculators. Go ahead and multiply and add it out, and we'll see what it ends up being. Go ahead, Jake. It should include the $2,500 because notice the grand prize is not just $2,500. It is the vacation. Who knows what that costs, but it's plus $2,500. And this said how much money will be awarded. So I'm not going to include the vacation in this because we don't know how much it's worth really. But we do know it's $2,500. Apparently that's spending money, so you can go buy snacks and souvenirs and, I don't know, whatever. Do special stuff beyond the regular Disney World special stuff. So what'd you get? Calculator people that have those with you? Got a total? Me too. It's very disappointing. Yes, Neil, go ahead.
The total?
Yes.
I got 11,875.
I did that all.
I didn't even use calculators.
Well done, and you were faster than the calculator people. So do you guys agree with that? I honestly don't know what it is. Don't look at me to be the answer man here.
It's a lot. He's right.
He's right? Okay, $11,875.
Yes.
Well done, Neil. And Grace. Nicely done. It's the highlight of my day, Grace. Get it? Yes. Okay. So that's quite a bit more money than if we just add them up, right? Because there's a lot of second place prizes and a lot of third place prizes, so on and so forth. Okay, so let's remember that $11,875. Look now carefully with me at question B. Question B says, what is the average cash prize? So that word average, have you guys seen this before where there's there's a synonym for average, and that synonym is mean? So the word mean does mean average. So if you see one of those two words, they really mean the same thing. How is it that we find an average? What do?
You add up all of them and then we'll divide
divide them by how many sections there are.
That's right. So you add everything up and then you divide by the number of numbers, or in this case it'd be the number of prizes, right? So let's remember in A we added everything up, didn't we? $11,875. So I'll put that right here. But then we need to divide by the number of prizes. You know what? I think I know this. 1, 2, 3, 4 prizes. No, are there more than 4 prizes?
There's 120.
How do you get all those prizes? Where do you get? I only see 4 of them. What do you see, Ashlyn? Once again, there's more than just one of them, right? That's right, good. So what we need to do then is take all those prizes. The first one, the $2,500 prize, there's only one of those. We need to add the number of first place prizes, of which there are 4. We need to add to that the number of second place prizes. There are 35 of those. Lastly, there are 85 third place prizes. So I'm going to add all those up and do the division. Sorry, that's right there on the top of the board. So 115, right? 115 prizes, what that adds up to be. So it'd be 11,000.
125.
Oh man, you know what? You're right. My bad. Thank you. So 125. So once again, I would say these larger numbers kind of go into the realm of maybe a little too big to do without a calculator. So I don't think I'd throw this at you on a quiz. But did you use your calculator, Joel? Maybe you didn't.
124, not 125. You can't add 5 plus 5 plus 4 and equal.
The grand prize.
Oh, yeah. Oops.
Why'd you growl at me?
Don't forget about the grand prize. Okay. Okay, so did anybody do the division yet?
95.
$95. Okay. Sounds reasonable. Okay, so $95 is the average cash prize. So this is what we call a weighted mean, because wouldn't it be fair to say that there were certain prizes that had more weight than others? Which prize carried the most weight? Which one? No, I don't think so.
No, it was the second place prize. Third place.
I think it's third place, because didn't third place have the most prizes?
Yep.
So I would say the grand prize had the least weight because there was only one of them. But I'd say third place had the most weight because there was 85 of those. In fact, I would say that third place had 85 times more weight than the grand prize. And if you think about it, look at where the average actually was. The average was $95. Isn't that a lot closer to 25 than it is to 2,500? It's a lot closer to 25 than to 2,500. And so you can see that the $25 weight really pulled the average down. An example would be this. What if, here'd be maybe a more practical example for you immediately. What if we took our test, I think it's coming up next week. What if we took our test? And can I pretend like I'm in the class? I'll insult myself here. Let's say I was in the class and I took the test with you guys. Let's say that every single one of you took the test and you guys had a great day and every single one of you scored a 100%. Perfect score. You didn't miss a thing. Let's say that I took the same test and I had the worst possible day and I got a 0. Would we then look at the class as a whole and say, well, all of you guys got hundreds, I got a 0, therefore the class average is 50. Does that make any sense? No. Shouldn't you guys have a lot more weight than my 0? Because aren't there a lot of you compared to one of me? And so do you see how the weighting works just conceptually? The weighting here, the 25 had a lot more weight, just like you guys all making hundreds would have a lot more weight than me making 0. The average would probably still be in the 90s, wouldn't it? In spite of my terrible grade, you guys all made hundreds. It's going to be a really strong average, not going to be 50. Does that make sense? Okay, fantastic. Any questions before we move on? Okay, so just a little bit of direct instruction here, and then we'll be at the board right away. So take a look at the start of the next section. We're going to talk about algebraic expressions, and that word right there. Have you ever seen that word? Polynomial? I hope maybe you've heard of that, possibly. If you haven't, you're going to learn about it a little bit. What you see right there is an example of a polynomial. And in that polynomial, we are going to identify the terms, and we're going to identify the coefficients. So I just want to do this here with you. And like I said, maybe you've seen this, maybe you've heard of this, maybe not. Either way, we'll hopefully be to a good place. Here are the terms. So the first term, I'm just going to go in order here, guys. I know you're taking notes, but stay with me here. We'll be at the board right after this section. The first term is 3x to the fourth. That's the very first term. The second term is negative 7x cubed. The third term would be 5x squared. The fourth term would be 12x. The last term would be negative 8. I'm just going in order there. And so how many terms does that expression have?
4.
It's got 5 actually. You got 1, 2, 3, 4, 5. 5 separate terms. Different terms are separated by addition and subtraction. Can you see that coming through there? The separate terms are separated by pluses and minuses. And a term is held together by multiplication or division. So you see 3x to the fourth. What's going on between the 3 and the x to the fourth? Multiplication. So multiplication is holding the term together, whereas subtraction and addition is separating the different terms. And then the coefficients. Have you ever heard of that word, coefficient? Coefficient is the number that is being multiplied times the variable within any term. So the first coefficient would be 3. I'm looking at that 3 right there. Another coefficient would be
7.
negative 7. The sign in front of the number will always stay with the number. What about the next coefficient?
5.
Yep, we got that 5 right there. Positive 5 is another coefficient. How about the fourth coefficient? 12. And then the last term doesn't really have a variable, does it? So we would call that last term, which is the negative 8, we would call that a constant. If you think about the word constant, doesn't constant mean never changes?
Yeah.
And so the negative 8, the value of that negative 8 will always be negative 8. There's nothing that it depends on, so it's always just going to be constantly negative 8. Okay, so let's test you out here. Let's see if you guys can do this. Let's do this together, but I want you guys to try to supply the answer. For number 1, for the algebraic expression, negative 3x squared minus x plus 5, I want you to think about this answer, and then we'll see what we think here in a second. First question, how many terms does that polynomial have?
3.
3? Anybody disagree with Grace?
Isn't it just
2,
2?
so 3 or 2. Anybody have a different answer besides 3 or 2?
No, I was going to say 3.
You're going to say 3? So anybody have something other than 3 or 2? So let's remember that different terms are separated by subtraction and addition. That's what separates, that's like the fence between the terms is subtraction or addition. So what I see is a subtraction and an addition right there. I see 3 terms actually. Do you see them also? The first term is negative 3x squared. The next term is negative x. The last term is positive 5. So there are actually 3 terms. What are the coefficients? So what's the very first coefficient we come to? What do you see, Jake? Negative 3. That's correct. Negative 3 is the first coefficient. The second one is like maybe a little tricky, right? Hosanna, do you see it? What do you think? It is negative 1. It says negative x, doesn't it? And so it's kind of like, well, what's the number that's there? Well, if it's a negative x or a positive x, the coefficient is understood to be a 1. So we would say this, because you could put a 1 right there. It wouldn't change anything. So the coefficient would be negative 1. It really doesn't. Negative 1 times x is the same thing as negative x.
But if it's like plus.
If it was plus x, plus 1x is still just plus 1x.
Yeah, so something is 2x.
Oh, but 2 makes a difference, right?
No, if it was like 2x and then plus x.
Plus 1x. So 2x plus x, we'll find out later, is 3x.
Yeah, that's
2 plus
so it
1.
does make a difference.
No, it doesn't.
But it turned the 2 into a 3 because you're adding 1.
No. 2x plus x is 3x.
Yeah.
2x plus 1x is 3x.
I'm saying.
So it really makes no difference.
Yeah, never mind.
Okay. All right. Let's see here. One more. Yes. Oh, I like this one. Then we'll get to the board. So in number 2, this is a good test of understanding what coefficients, factors. You know what? Let's use the right terminology here. I'll put coefficient. So in number 2, A and B, is C used as a coefficient or is C used as a term? I want you to write this down on your page, okay? You haven't been writing anything down. You're over. Yeah, so factor is a correct word, but I think coefficient would be more consistent with what we just talked about. So put either coefficient or term. Is C used as a coefficient or is C used as a term? Give you just another moment here to figure it out. All right. Will, what do you think? You've had a chance to write it down here. What do you think about A? Is C a coefficient or is C a term? What do you guys think? It's a coefficient, or you could call it a factor. A factor would be just as accurate. But it's 32 times C, right? What operation holds terms together? Multiplication. Do you see how it's 32 times C? So you could call the 32 a coefficient. You could also call the C a coefficient. Factor is probably the better word, but I wanted to be consistent with what we've been using here. So I would say in A, we could call C a coefficient. Let me take it one step further. In A, how many terms do you see? In A, there's one term, right? Because it's 32 times C. That's the only term, and terms are held together by multiplication. So in B, is B the same thing, or is C being used as a term there? What do you think? It is a term. In fact, if we wanted to take it a step further like we just did, how many terms would you say are in B? 2, because you see the 9 minus C, right? So terms are separated by addition or subtraction. You can see the subtraction there. Okay, let's head up to the board. We're going to do some translating of some algebraic expressions. We've done this before. I just want to see where we are at still with it. So let's go to the board and try to translate these. If you're at your seat, try them. You've got them in front of you. Try them as well. Let's do number 3. Do number 3. 17 less than the weight W. Translate that into math. 17 less than the weight W. 17 less than the weight W. Good. Good. No equal sign U. It's the other way around, actually. So think about the practicality here. If you ask me,
Wow, really, like,
if you ask me my age,
really proud of your answer.
and you guessed my age and you said,
I know, except for
I'm
this
like,
part.
let's go 8 less than that. Would you go 8 minus 50 or 50 minus 8? Because I said 8 less
Do you
than
see how
that, right?
beautiful this box is?
Okay, W minus 17, fantastic, great job. So W minus 17 is definitely correct. Okay, let's go up to the board. Next group. Okay, so this one brings in the key word of. What does the word of most often mean?
Multiply.
Multiply. So use that to try to translate this into math. Let's avoid the X. Let's go with maybe the dot. Yeah.
That's worse.
It's understandable. Oh, Cole's getting free. Nice work.
Done.
Yep, that's good. Remember, order doesn't matter here, so if you've got P times 3/4, or 3/4 times P, it's the same thing. Those all look really good. Nice job. It's the same thing. Multiplication is commutative. All right, let's go. Number 5, head to the board.
Wait, actually? Go Kendall. How do you know that? Because it has a P on it?
This gets a little tougher now.
But how do you guess
product-
Elizabeth? That's like the most common one.
The product of the costs C and 4 increased by 9.
Grace, Emery, Emily could be Grace.
Got it.
What's up, Elaine? You know that one word that sounds like emerald?
Got it, Anna. Good job.
Esmeralda. Esme? No, it's like Eleanor.
So, what is the product?
It reminds me of a whoa.
You definitely want to know. Product means multiplication. So, the product, so the multiplication of C and would be 4C or C times 4. I like 4C better.
Isn't it D divided by 9 in parentheses squared minus 9?
Let's use like a dot or maybe some parentheses. We like to do that.
It doesn't
Yeah,
matter.
it's 9
That's good. It's a different way of writing it with 4C, but that works.
I'm also good at making
And then
circles.
increase by means that we added to it.
It's more of an oval than like a circle.
Nice job, Victoria. Nice job. 4C plus 9. Both of you. Nice work.
Oh, just kidding.
Okay, let's do number 6. Head up there.
Here. Wait.
Number 6 is a little tougher. You can see.
I beat you.
So number 6.
So
Right?
Difference of
Mr. Anderson?
twice.
Sit down, Paul.
Well, that's just impressive.
Twice D. What does twice D mean? Times. Whoever said that, yes. The difference of twice D and 9, comma, cubed. A little tougher. That's closer. That's a lot closer, but it's still not quite there.
I'm there.
Ask yourself what is being cubed. Oh, no. No division going on here. There's you get 2
Oh, wait.
There, I did it.
You guys are all squaring D. Twice D. So think
Am I
about
right?
this. What if you were buying something from me and let's say you offered me $50 and I'm like, you're gonna have to give me twice that? Does that mean 50 squared? What does it mean? There you go. Twice D.
Wait, I did the parentheses
Yeah,
wrong way.
you gotta open them up.
Am I right?
Did I do this?
Nope. Sorry.
Really wrong.
I'm getting.
Let's not use extra times.
Wait. Oh, I
Got
got
it?
it.
Use a dot or parentheses. If you do that,
Okay.
you are the closest.
Minus
One little detail
9.
that's not right, you can do it right. There you go. Check out, Jose. Just one little thing.
I think I'm right.
You're a little close.
I'm right.
That's right.
I
Close. Don't give me the-
Oh my god.
It doesn't say 9, it says that.
It's
Face is
different.
like a salt.
The difference is between.
I don't think the two.
That's right.
Is this right?
That's right. Yeah, so it's telling you that the wording is it's saying that the difference is being cubed, right? You are only cubing D minus 9, where the difference was 2.
No, sounds good, sounds good.
You want to cube the entire thing.
Well, but this is a multiplication.
But it's,
This is a subtraction.
but great.
I just skipped.
It's okay. So what it's saying though is that it's the difference of 2D minus 9, and we're supposed to cube that whole thing. So we're not going to take out part of it and cube it, we want to cube the whole difference. The whole thing. The difference was between 2D and 9. All right, so Connor, you're only cubing the 9.
Which one is black?
It wants you to cube the difference,
Black is the top.
right? So it's saying the difference of blah, blah, blah.
Black
is
is
cubed.
bottom.
There you go.
They're both blue.
All right.
Oh, I thought it was a black is the side one. I thought it was a track.
All right, good people, let's do the last one.
I thought it was
Last one.
Yes, it does.
Number 7. Oh, Cole, is that what you were doing? Were you actually doing number 7?
What?
Were you, when you were up there, you were doing like division? I thought maybe you were actually doing number 7. Okay, so do number 7. The sum of the quotient of y and 9 and 3.
Quotient and division.
That's good. Yeah. Kendall, not quite. Sum of, so sum means addition. So we're adding some things. Joel, that's right. Cooper, that's good. Lana, that's good. Same thing. Oh, you know what? Shoot. No, Lana. It's plus, yeah. I connected the dots for you. It's
Yay!
gotta be
Woohoo!
plus. All right. Y over 9 plus 3.
No, guys, guess what I told
That's
this
good.
kid?
What?
Y divided by 9.
Brian is.
Divided by 9, you got Y for 3.
Okay, well, anyways.
That'll be over 9. Yep.
Yeah. My biology.
Tori, that's good. Nice job.
You're such a
Y divided by 9. Is that a plus, Ashlyn?
Whiteboard.
Plus 3. Yeah, Carissa also. Great job. Both of you did well there.
I was like, yes, I did. And I was like, you were
What was it about?
Yeah. I named it silly, so I can call it a silly goose. Yeah, it was very funny though. I thought it was funny. I was laughing real hard. He was like, you're really weird. I was like,
I just think she's so overrated.
I was like, take me to homecoming.
Okay, guys, we're going to continue at the board. Let's check out number 8. So this is a more of an application setting. So number 8 says the semester tuition cost for a total of 15 credit hours is X dollars. Write an expression that represents the cost of each credit hour. The semester cost for 15 credit hours is X dollars. Write an expression that represents the cost of each of those credit hours.
I don't think that's right.
That was easy.
It is right.
No way.
Yes way.
Oh my gosh.
Nice work. That's exactly what you do.
No way.
I don't know if this is right.
I am amazing.
That wasn't good.
That just made my whole day so happy.
15 divided by Patrick.
It's not minus. I'll explain minus. That's right. And Garrett is multiplying. That's right. So X is the total cost of the semester for 15 hours. So if the
Grace
total
got
cost
Is
is
this
X,
what you wrote? And she got her mojo.
spread out over 15 hours.
Yeah, that's it. I mean, I'm gonna do some
Yeah, that works.
That was not a good box.
Yep. X over 15.
It's like
X divided by 15.
and then
Yeah, it is. It is.
It's called art.
Yeah, I wish we could avoid the whole copycat routine. It's really not helpful at all. They'll find out. Grace, but you can feel good because you did it first, right? All right, number 9. Let's head up to the board. It says Tom is 3 years older than Joan. Carly is 5 years younger than Joan. Write algebraic expressions to represent the age of each person. So write one for Tom, one for Joan, one for
no one knows how
Carly.
Joan is.
That's why it's going to be an algebraic expression. So let's do this. I'll tell you, hey guys, hey, listen up. Before we get too far in here, let's say that Joan's age is J. So if Joan's age is J, let's write an expression for Tom and Carly. So T for Tom, C for Carly. Which one is which? Yep. Good. Good. So,
Just kidding.
3 years older, right? So if I say you'll graduate from high school when you're 3 years older, that doesn't mean when you're 42, right?
Hopefully.
You're like, please don't let it be 42. That's good.
Okay.
Thanks for helping with that. There you go. You got it. No, I'm so sorry. I flipped it around.
I got it right, Dad.
Did I try it?
Order better. This is right. This is Jason.
Yeah. No, that's not right. No, that's right. I was looking at it upside down.
That looks good. Cooper, Lana, you've got it. That's Tom. Keep going for Carly.
How many seconds are X minutes?
That's good.
That's dumb.
And that's good. Good job, Krissa and Ashlyn.
Josh tried to
So Carly is 5 years younger.
What is this minute? Just make it question mark. 60.
do golf. Golf.
Okay.
Oh shoot, we have to go out there. Like this honestly makes no sense.
Let's do these. Hey guys, we got just like a short amount of time left here. Let's do these together. And we'll get out of here. How many seconds are in X minutes?
Depends how many minutes.
X minutes.
Oh, it's nice.
Go ahead.
So S, seconds divided by X.
Not divided by,
Multiply.
it's multiplied by. So the number of seconds in X minutes would be 60 times X. So, hey guys, hey fellas. So if there was 5 minutes and I wanted to know how many seconds, wouldn't you go 5 times 60? So if there's X minutes, you go X times 60. And then lastly, number 11, the total value of D plus 1 dimes in cents. What would we write? I don't know how many dimes I have. I've got D plus 1 of them. What do I need to do with that to know the total value in cents? Multiply by 10. So tell me exactly what to write.
So it would be, D,
A D plus 1
or
times 10. So that would be incorrect. But if we did the parentheses thing like you said, that would make it correct. It'd have to be the entire D plus 1 times 10. Not just the D, not just the... Okay, so that's our class for today. Hope you guys have a terrific day. See you tomorrow. You sure could.
Hi.